All right. How's everybody doing tonight? Let me get some of this stuff shut down here, get us all set for the show. Okay, why isn't this working? Okay. Hopefully, let me check the sound. Hey, Ryan. Well, you're on time tonight. Nice and early. Hey, Rick, how you doing? I haven't seen any updates on the 55. I guess that cold weather up there has got you slowed down. Always like to see those updates. You too, Ryan, with the truck. I haven't seen anything in a little while. I know all this small stuff takes a lot of time, so. Yeah, so another week's gone by. We got, I think I said last week we had picked up Dave's car. It's actually in the shop now. Been working on the on Scott's 8.1 big block. Too cold still. Yeah, I get it. So on the 8.1, I about got that thing finished. Actually painted the block and stuff today. Pretty much wrapped it up. So that's been going on. Oh, man. Sorry to hear that. Hopefully everybody's okay. Ryan's had fixed his daughter's car. I too, had to fix my wife's car last week. Water pump went out on that thing. That was a lot of fun. So, yeah, hopefully everybody's okay from that. Tornadoes doesn't seem to matter where you're at. We just had a bunch of them go through down here again. A new batch of storms that went through. Luckily, I didn't see any damage around here, but yeah, so the 8.1's just about finished up. Been working, trying to get more stuff done on the on the NASCAR Cup car. I am currently registered to go to Talladega to Darlington Raceway on the April 5th and 6th for the Xfinity race. It's Darlington's throwback weekend, and so the Stock Car Classics group on Facebook are going there. We're going to be in the fan zone with our cars on display, and I believe right after the Xfinity race, we're going to get to go on track and do some lapping on the track. So, got a couple of things I got to get finished up on that. I got to get some work done on my truck. Make sure you get the camper loaded up because we'll end up camping up there. But that should be a lot of fun. I don't know what the future holds, but it may be the last hurrah for me and that Cup car. So I thought it'd be pretty cool to have on the channel as kind of the final chapter of it, so to speak. So that'll be pretty cool. Obviously, I'll try to get some video on there. I'm gonna definitely try to get some in-car and stuff like that. Chuck and Dave came over this weekend, and Chuck's just about got all the paint work done. We cleaned the rear, welded the tubes. It's 10 bolts, so you got to weld the tubes to the housing for higher horsepower. Got that all painted. Got the new wheel, 14-inch 4-piston brakes on the rear end housing, so the rear end housing is now ready to go back in the truck. So hopefully next weekend we'll be able to make that truck a roller again, and then we can start working on getting the engine bay painted, and then we can start doing the motor and training and that bit of install, and then eventually getting the hot and cold sides on the turbos done. So that's moving along a little bit. On Dave's car, we got it put together real quick so we could get it down to the paint shop so they could do the cut and buff on that, and they had to put some of the trim back on and stuff like that. So I noticed before it left that the fuel pressure was really low, and the brakes were kind of sticky, and that was kind of the same thing that I found with Joe's car. It seems that the Hydro Boost and the Willwood master cylinder, the pin that comes for the booster, is a little too long when you're using Hydro Boost. So I cut that down some. Seems to have freed up the brakes quite a bit. I may need a touch more. I got to measure it one more time. But I kind of assumed that the regulator had a bad diaphragm on the Holley fuel filter regulator combo, and put a new regulator in it the other day, and boom, 60 pounds of fuel pressure like it's supposed to be, which that really helped the car run a lot better. And of course, I don't have any tuning done, just some initial, and I had to do some fitting to the block off on the IAC on the second throttle body, but I've got that working now, so now there's no air bypassing on that throttle body. So the IAC in the driver's side is doing all the control. And being that they had the hole in the diaphragm, the car starts now because the fuel isn't draining back into the tank every time you shut it off. So made some headway on that. Possibly tomorrow I'm going to try to get the dash out of it and get the major part of the wiring done so we can get the car inspected and get a tag for it so we can start doing some test driving and getting that thing wrapped up. Hopefully I will try to get some video on the car maybe tomorrow before I take the dash out, so that way I can show you guys. I was going to try to do that this week, but it just kind of turned into a crazy week. My buddy Mike Smith was down with his 66 Chevelle, and we've been having an issue with the 4L80 not having second gear. So I came up, I didn't come up with it, I found it on the internet, how to make an electrical plug that you can make your 4L80 computer controlled transmission manually shifted using the electronics in the transmission. So did that. We ran the car on jack stands, and it had all 4 forward gears. Hooked the Holley back up, and it didn't, and we went around and around, and maybe we'll go over that in a minute here, the findings there. But made some progress. Keep moving things along. So that's pretty much, I guess, what we got accomplished this week. Week kind of went by super fast, but yeah. So I wanted to go back to the engine blueprinting series that we were doing. I know we had a couple car shows in there and kind of put us back, but this is kind of basically the last section of it for now. And when Mike gets on later, I want to show him some stuff I found with the torque to yield. So let me go ahead and what is going on with this? There we go. Okay. So hopefully the sound is going to be okay on this thing. So let me make sure it's. Let me know if the volume changes a lot on this. But here's just these aren't edited yet. They're just pieced together. So we'll actually we don't even need to do the camshaft one. Yeah, so we'll start on this one here. You want to put some type of cam stop in the engine. Now, this engine was originally designed for hydraulic roller, so it has a plate that goes between the block and the gear, and that keeps the end play of the camshaft. Now, if you're doing a conversion from a regular block to a hydraulic roller or to a solid roller, you have to put some type of cam stop in there to keep the cam from walking, because if the cam walks, it'll pull the rockers, it'll pull the lifters, and they will turn and it'll start grinding the cam and it'll wear the cam out. So you definitely have to always check your cam end play when you're doing a roller lifter. All right, so hopefully the sound is pretty level there.
All right, so we
here's
need to
about
install
this
the
rear main
rear
seal.
main
This was
seal on
something
this
unique
8.1.
to this engine.
And these are a little
I just
different
thought it'd
than
be
what
good
you're
to
typically
show you
used
guys.
to. This is actually a two-piece Teflon seal. And it has to be, you have to use a special tool to put these in. So you get the new seal to be in a sealed package because of Teflon. They don't want any chemicals getting on it. Then we use the Kentmore tool that actually takes these and screws into the bolt holes in the crank, and then the outer shell then pushes the seal in perfectly square to the crank until it seats. And this tool actually bottoms out to put the seal in the exact location it needs to be in.
Thanks, Ryan, for letting me know about that.
So this is the new seal, and this is the engine side. This is the flywheel side. Kind of put it on there, get it started. Take the tool. Once that's tight, you just start tightening this center nut, and it pushes the seal on.
Yeah, so there's a lot of the newer vehicles use this type of two-piece seal. Unfortunately for us, it requires a tool, special tool to put it in. That's why I wanted to show you guys this, because I wasn't even aware of that until I got involved in this. Luckily, I was able to rent one from somebody on Facebook, so let me go ahead and let this finish. All right, so we have the camshaft in. We have the timing. Sorry.
Once it's tight, you're done. And with that, we have the seal completely installed, and it's sunk in at the correct location and the correct depth. Perfect install. So just remember that when you're doing the rear main seal on these engines, you have to use that tool.
Yeah, so that was the rear main seal install. And like I said, that's a lot of the newer cars use that. LSs all have Teflon lined seals now instead of using the neoprene typical oil seal with a spring behind it. They don't use that on these new motors. So good for us. The LS stuff, we don't have to use a special tool to put them on, but the Duramax and these 8.1s, pretty much any of the Mark 6 big blocks, it requires that special tool to put the seal on. So that was a learning experience, but we got it done. And so now I want to go ahead and we'll get caught up to with the degreeing the cam, and we'll go from there. So here we go again. We have the camshaft in, we have the timing chain on, we've got our degree wheel set up, our deck gauge, and our cam follower tool. So now what we're going to do is check the
cam timing. Make sure that the timing of the camshaft is correct. So the first thing you want to do is, using your deck bridge, is find TDC. So there's always a bit of rollover as the crank journal goes across. So the easiest way to find it is to kind of set yourself up where you think it's close, and then go back to where the piston's down 50 thousandths, 100 thousandths, whatever number you want to use, just so it's the same on both sides. So we'll stop it at 50. We'll read the wheel. Then we'll continue on, up, and then back to 50 again. And at that point, you should have the same reading on both sides. If not, adjust and recheck. So we've already done that. This motor is on top dead center. And so the next thing to do is we want to set the cam follower on the base circle of the cam.
Unfortunately, I don't have these edited yet, so that would have normally been cut out.
So when the indicator is all the way down and it's not moving, we're on the base of the cam. So now we'll rotate it around. This cam card calls for 6 thousandths of lift on the duration to read the cam spec. So we'll rotate it around. Stop at 6 thousandths, and we're showing 15 degrees before top dead center. Now we want to go to the other side, so we're going to count the revolutions as the cam lobe is going up, and then we'll be able to find it going back down. 1, 2, almost 3. So that same thing back. So 1, 2, and back to 6 thousandths. Then we'll read our wheel. We have 63. So then we go to our cam card and see how we are compared to how the cam was ground.
Next one.
All right, so let's check this one more time. We're on the base of the cam. Notice the indicator shows 0. You get to 6 thousandths, and we read 14. Count the revolutions around. That's 1, 2, 3. Which the cam card calls for 298 thousandths lift. So that is correct. Now we're going to count it backwards and stop back at 6 thousandths. That's 1, 2, and then this one's going to be at 6. And we read 62 degrees. So we're going to take our 15 plus, I'm sorry, it was 14. 14 plus 62 plus 180 equals 256 divided by 2 equals 128 minus 14. And it shows the cam is at 114 degrees. The cam card calls for 115, but 1 degree is not going to be enough to worry about making a change. So we've degreed the cam, and the cam is correct. Now, if you wanted to check your cam specs, you could put this in the exhaust port hole and do the same process, and you would have the camshaft lobe lift, and you would have the opening and closing times, which would give you the exhaust center line. Then you could take the two center lines and add them together, divide them by 2, and that would give you your camshaft LSA, lobe separation angle. So all that is checking out good, so we can continue on. We can go ahead and put our lifters in, put our timing cover on, and we can get ready to put the cylinder heads on. So let's go ahead and do that.
So, yeah, Rick, it is a pain. You have to take the engine off the stand to use that tool. That was kind of a real pain, but you know, you got to do what you can do. Chris, I see you are in. Hey, man, how you doing? Ryan, to answer your question, I have done it in the past. Typically, I don't do it after the valve train is in. Only reason being is the only difference is the pressure of the springs, you know, and which is going to give the camshaft extra load. But like on the 4200, I have to do that one with the with the engine, you know, assembled, and I do it that way. But it doesn't really change anything unless you have something loose. Like if you have a sloppy chain, then it's a possibility you get different readings. But that's why whenever, and I didn't say that in that video, whenever you are going backwards with the engine, say you're going backwards to 50 thousandths, you got to go beyond the 50 point, maybe by 60 to 70, and then come back to rotation. You always want to check everything in the rotation of the engine. That way your timing components and stuff will always be tensioned the way the engine spins. You're always going to get a little slight bit of play in your chains. So like on the 4200, double overhead cam with guides and everything, so the you can't tension the timing chain so tight that there's no deflection. The guides will just wear. So you have to find a happy spot where there's a little bit of play, maybe a degree or two of slack, but of course the engine only spins one direction, so it's always pulling. The crank is rotating, pulling the chain around the cam sprocket, so the cam is always going to be in the same position. Maybe on DXL or something like that it might move around, but for performance wise, when you're on the throttle, it's always going to come back the same spot. Now, depending on the engine, like I said, overhead cam motors, a lot of times you do have to degree them, or it's a lot easier to degree them using magnetic base and the indicator touching the retainer, and you just follow the retainer up and down, holding the spring. But when you're assembling a push rod engine like these, it's just easier to use this tool. Now, when I get the 351 Windsor video finished, you'll see in that one I actually use a push rod and a lifter with the magnetic base going on top of that. So you don't have to have this particular tool. You can just use a magnetic base dial indicator, like you can buy them at Harbor Freight for $30. So you can kind of do that anyway. Right on the money. Yeah, you're right on the timing chain. Now I've seen back in the day that was something we were gonna install a used engine or something. Rick remembers back in the day, the early days of street rods and classics, going back to 1989, when we were building. We thought we were the dudes, man. We were taking all these Tri-5s and putting a small block and a 700 R4 and disc brakes on the front, and we made these cars, you know, popular and current. You could drive them on the highway. We didn't know about all the stuff that we know now, but a lot of times back then we would do used engines, and that's one thing we would do is we would watch the valve train and rotate the motor back and forth to see how much slack was in the timing chain. And I can't tell you how many motors I've seen with 12, 14 degrees of rotation before the camshaft catches up. So then at that point the motor's got a lot of wear. You got to at least take it apart, inspect it, put a timing chain in it at least. And then of course, so a lot of you guys may not have ran into this before, but when you have a engine block line honed or line bored, so you get a block that spun a main bearing in it, you want to save the block. If the block isn't too bad, you can take it to a machine shop and they'll resize the mains just like they resize a connecting rod. So they grind the cap. That way it lowers the circle, makes the bearing insert portion of the block small, and then they run a boring bar back through the block to open back up to where it's back to the original size. Yeah, Rick, you're right. Nylon gears, they were crazy about that stuff. Find them things, all the chunks in the oil pan. It was great. So the only problem with when you're doing that, a lot of times on a connecting rod, all the material is the same, so it really doesn't change when you hone the center length from small end to big end doesn't really change when you resize a connecting rod. But on an engine block, most of your performance blocks, the block is cast and the caps are steel. So obviously the cast iron will machine easier than the steel cap. So what ends up happening is the crankshaft center line actually is moved up in the block 2-3 thousandths. I've seen 5 thousandths, even a tick more. So if the block has been line honed or line bored and then honed, you have to check your distance from the center of the cam to center of the crank. They do make oversized crank sprockets that will tighten up the chain. So they'll have a standard distance and they'll have a 5 thousandths distance timing chain. So if you're moved up 3-4 thousandths, you can put the 5 thousandths chain in there and it'll be nice and tight. If it's more than 5, you might not even want to use the block, but that's one way of doing it. Of course, with some of the racing belt drive systems, I think Comp has one that actually has an idler, so you can tension the belt. But those Gilmer style belts don't like to be really made tight, not like a V belt or a serpentine belt. So you have to be careful with that. So that's the main thing there. Now, I didn't do on this motor is I was going to go ahead and do valve show about push rod lengths and stuff like that, but this particular engine, get rid of this. This particular engine has bolt down stands, so there's nothing to be done about that. So I moved on, and plus I had all the stock stuff in it for. Here's one other thing I wanted to show you guys when you're assembling, especially Chevrolet, some of your Ford engines. Not super hip on Mopar, so I don't know how many Mopar blocks, but any block where the head bolts go into the cooling system, this is something, little tidbit. Ryan says, I've been concerned about this. My block in the Vega is aluminum with titanium caps. Yeah, so if the line bore's messed up on that, you're going to have to, here's a new process that's available now that not every machine shop has, but the Rottler, I think it's a F65 or F45. There's a new Rottler CNC engine block machine center. Steve Morris has one on his channel. A local guy here, Tim Eichhorn, has one in his shop. And this is a machine center that takes the block front and back and puts a bar through it so it can rotate the block, and you put in the coordinates for what block you're using, and it can, from having the plates bolted onto the block, it can shift the motor so that it can do a deck clean on it, and you don't have to calibrate the machine. It already is going to rotate it, lock it, and it will be perfectly square, the cylinders, the way the motor's blocked, and then they can cut it. But this machine will do multiple things. You can bore, you can put fire rings in, where they put a stainless wire retainer in the block or in the head. Block is better, so that you can get extra pinch on the head gasket if you're in a blower application. But they also make an attachment, a 90-degree attachment. It will actually do camshaft journal and main cap bores, and that machine centers itself to the crank center line, and then it can go in and bore it. And being it's using a cutter instead of a stone, it can actually cut out of the aluminum and the titanium at the same time. Whereas when you're using the traditional boring bar style line bore machine, it's going to take it from the easiest thing. So obviously an aluminum block, it's going to take it out of the aluminum and not touch the titanium. So if you do, Ryan, if you do need to have that block line board, you need to call around and find somebody that has one of those Rottler machines that can actually go in and cut it with a cutter so that it can cut evenly all the way around. I think at that point it still moves the crankshaft up a little bit because it has to cut into the aluminum, but it would be very minimal, maybe only a thou, maybe a thou and a half. No big deal at that point. But look that up. Like I said, Steve Morse has a couple videos on it because he had just recently got that machine. In fact, I think his last Thursday show, he was showing putting a thrust bearing kit in Cletus's Brodex block, and he used that machine with a cutter in it to spot face the first main cap to make a register where his rollerized thrust bearing would go in. So take a peek at that. It's pretty cool how that works. Like I said, anytime you got a block that head bolts go into the cooling system, this is a good little tidbit for you here. Let me go ahead and fire this up.
Another thing you want to do on any engine that has the head bolts that go into the cooling system, you want to clean the threads. So use a thread chase like this. It's not a tap, it's a chase, so it doesn't cut new threads, it just cleans the threads. And you just run them in and out. Make sure you have good clean threads for the head bolts. You don't want any binding. This bolt wouldn't tighten properly if we didn't chase the threads. Now we have nice clean threads. Double check these bottom ones again. And now we know all the head bolts will tighten to the proper spec, and not because of binding in the threads, but actually for clamping forces. So just a FYI for any motors that have cooling system or coolant behind the head bolts.
Yeah, so you can see in that video. Now this block that I'm using for this 8.1 probably only had maybe 100,000 miles on it, and the cooling jackets are pretty clean. You can see there's no corrosion or anything around the edges, but yet the bottom head bolts did have corrosion in the threads, and when you're torquing your head bolts, that's going to create an issue if you have any drag in there. So just a good thing to remember, that if your head bolts go into coolant passages, you should check all that before you put it together. Yeah, Ryan, those machines are badass. You can do lifter bores. You can also do stroker clearance. That was amazing to watch how it rotated the motor and the cutter as it was going through there to where it was making a full semicircle groove through the bottom end, where normally you'd have to do that by hand, or you'd have to go in at multiple angles with a end mill in a milling machine. Where this thing does it and makes it nice and clean, and I mean, it makes it perfect looking, like it was made that way. So that's definitely, for that motor, if you have to do anything with that, you definitely want to look for one of those, and go in that direction. So yeah, so I got that thing all pretty much done. So I don't see Mike in here yet tonight, but we'll go ahead and we'll go over this, and he can always catch it up on the next show, or on replay. Now this I didn't get a chance to rewrite this, but let me go ahead and go back over here. So one of the things that Mike and I were talking about a couple weeks ago was the torque to yield. Now, I don't know how many of you guys have had the pleasure of doing torque to yield. All your new cars are all torque to yield bolts. Most of your performance stuff, we go ahead and go to aftermarket stuff. Ryan says, I had a cam failure on a stock big block roller due to lifter board not being square. Yeah, definitely. And the other thing too on rollers is, anytime you put a roller cam in a block that wasn't originally made for a roller, you have to check your camshaft end play, because if the camshaft can walk in and out, your lifters will be forced to go into a bind, and you can a lifter can bend the bar, and then it'll go sideways, and of course then the wheel won't roll sideways. So got to really, whenever you're dealing with a roller cam, you got to really be careful with that. Now, of course, that 8.1 block was a roller block from the factory, so it already had the proper plate and the proper clearances in the camshaft and all that. So you put it together, you check it, it's got like 2 to 3 thousandths end play, you're good to go. But when we were talking about torquing bolts, Mike mentioned how when you do torque to yield, we both have a snap-on tool. When you're done with this, when the pull, you get to your angle, the torque wrench will tell you what torque it took to get to that point. And Mike made the comment that when you're done, they're all over the place. And I was saying how I like to keep track of all that, because that'll tell me if I got a bolt that's going bad, because we're reusing torque to yield bolts, which the manufacturer says you shouldn't. As long as the bolt hasn't been stretched, there's really no reason why not to. So this is a little sheet that I came up with. Now this is 4-bolt main, so you got the 2 inner bolts on the main cap, and then the 2 outer bolts. That's what these circles are. And then of course there's 5 mains on this 8.1 motor. And if I remember correctly, they get torqued to 22 foot-pounds, and then they go 90 degrees, I believe. And so I did it one time. I didn't print that page, but I was, when you're torquing them to 22 foot-pounds, it's very light. So a lot of times if you're running bolts in with a gun or with a ratchet, you can already have them beyond 22. So when you go pull 22, it says, oh, 22. So I just kind of did one half, not really super paying attention to everything. I just checked them all at 22, then I did a 90, and Mike is right. The numbers were all over the place. Then I decided, let me loosen everything back and do it as they say. So on these were all torqued at 22, 22.0, 22.1, a couple with 22.2. It was really hard to get it exact. And then it pulled 90 degrees. So you can see now these bolts are a different length than the outer bolts. But you can see we have a high of 114.6, and we have a low of 101. So we're relatively close to 15% variation front to back. And that's what I was talking about, that how you could check to see. Because now if we had one that was 25, 30 percent low, then we'd say, okay, we got a problem. So then we went to the outside bolts and we did the same thing. Torqued them as closely as could to 22 and pulled them. Now I did find a couple of the short ones. We did have a couple that went pretty high. But still, again, it was relatively close. And that's kind of where I was getting at. It's not an exact science, but you can kind of feel when a bolt is giving up. And that's why I just wanted to show this. Now, these other numbers here are connecting rods. And again, the connecting rods are torque to yield. And the other thing I have to say is all these are factory bolts, so they don't have any molly on the threads or under the head of the bolt to stop friction, as the bolt's tightening up. On factory bolts, with the torque spec that they give you, it's made for just a very light film of 30 weight oil. So there is possibility of some friction affecting your 90 degree on your torque to yield. So that's why I think there's always going to be some variation. But you can even see on these connecting rods, I mean, these were 22, 90 degrees, and they're all really, really close. This one here was 59.7, but still fairly close, and I think that was the highest at 67. So I just wanted to show that. I think if you really take your time and you can really make them all really close in proximity to each other. I think this little variation we have here is more the friction of the bolt tightening than it is the actual bolt giving up or doing whatever it's doing. So just wanted to show that. And if Mike does watch this over again, or if he's here and just hasn't chimed in, just food for thought. Kind of cool, I thought, to check these things out, especially if you had to replace all the bolts in the motor. I mean, you're talking a couple $100. So I have no problems with reusing all the hardware in this motor. I think it'll be fine. And so I just wanted to show you guys that. So the other thing that was our big deal this weekend was working on Mike Smith's car. So, like I said, he had, I built the engine for it. We've showed a couple pictures of it on the channel. It's the one that we had a crank sensor that was pinned wrong, and that was a while back, one of the early shows. And we've been driving the car to shows and stuff like that now. It's running good. Just it seems to go first to third without second gear. So I was talking over with my buddy Jonathan, who does our transmission work, and we're trying to figure out how we can test this thing, because the Holley Terminator system, whether it's Terminator or Dominator, doesn't make a difference. They don't give you trouble codes like an OE does. So you got to kind of, back probe and check voltages and stuff like that. And we don't have a dyno here, so it's hard to have the wheels spinning with load to where we can actually test each circuit. So John and I were talking at the Cool Wheel show, and I mentioned that I had seen a contraption that would convert your your automatic 4L80 to a manual shift transmission. You wouldn't need a computer. So let's see, okay, so there it is. I gotta turn this around. Okay. So here's what I found. You can buy these things on Amazon and eBay and some performance shops, where they'll give you the connector that plugs into your 4L80, and it has some wiring on it, and then it's got a little box, and it's got a 12 volt diffuse. So I did some more research, and actually what they were doing, and I had two harnesses that were GM repair harnesses. So it was the connector that goes to the transmission and about 2 feet of wire, so that if a car was in a fire or something like that, or whatever, connector's damaged, you could repin the harness. So what I found was the PSM is the pressure sensor module plate. So in the transmission, there's a pressure sensor plate that relays information back to the computer when those circuits are either energized or not energized, and it actually gives them a pressure reading. So what I found was, in the pressure plate A and B, you could connect those two wires to your shift solenoid 1, 2, and the pressure sensor plate C, terminal C, to your 2, 3 shift. So what happens is, when these pressure switches are C pressure, it sends ground out. It's a ground output. So we send those grounds to the one side of the shift solenoid, and then the 12 volt that goes to an ignition fuse is sending 12 volts to the shift solenoids whenever the key is on. So when you have the transmission in 1, the pressure switch notices it, and then when you shift it in the second, it sees it in the switches, and it energizes the 1, 2 shift module, so the transmission manually shifts in the second gear. And then when you see on the pressure switch C sees pressure, it sends a ground signal to the 2, 3 shift solenoid, and again the engine or the transmission shifts manually to third. So you don't need a computer or anything to make this work. Now, the caveat is that your line pressure is wide open. So on a car with a tight torque converter, it's going to slam the gears pretty hard. And this wasn't something we were going to drive the car around with. We were just using it as a quick diagnostic tool. So we jacked up his car. I hooked up the Holley to my laptop. I'm data logging, and we left the output, the TOSS, connected to the Holley. So the Holley sees speed. And you could see we're in first gear manually. The tires were rolling. Now it's just with the engine idling and the rear tires in the air. It was about 5 miles an hour, 4 or 5 miles an hour, kind of bouncing around between that 4 and 5. We click in the second, it jumped up to 10, 11. Click in the third, it would jump up to 22, 23, something like that. I forget the exact speed, but you could see a variation in speed on every shift. Now, of course, there was no load, so you couldn't really feel it shift, but you could see it shift speed-wise because the back tires were spinning faster. So then I went in the Holly and commanded 1800 RPM, and the IAC opened up, revved the engine up, and maintained it at 1800. And we redid the test, and obviously the speeds were much higher, but you could see that there was a shift, and a shift. So we figured, okay, the transmission must be working okay, so maybe it is in the electronics. So at that point, we already had the one connector apart, so I went ahead and pulled the connector off the ECU and the connector at the transmission, checked the pins, made sure all the pins were fully seated, and made sure all the wire colors were in the right positions. They were. So we decided, hey, let's go take this thing for a road test, connecting the Terminator back up. So we did that. We go down the road, shift, first, takes off, go into second, nothing happens. We're like, what the heck? Go into third, it shifts third. And we're kind of messing around with it, doing all kinds of things. One of the other caveats I didn't mention was that Mike's car has a 3-speed shifter and not a 4-speed shifter. So we went back, we had a 4-speed shifter, we stuck that in there to see if the positions on the selector valve in the valve body may not have been on the detents on every test. When we were doing it with the wheels in the air, we were using the cable only, so the detent in the trans was the only thing that was controlling that. That still proved to be the same outcome. So we were really kind of baffled what was going on. So we came back, we put the jumper back in the car. We didn't drive it like that, but we did roll up and down the street. And it's weird, we found that first gear was definitely connected. You really couldn't feel second. Click in the third. But if you downshift back in the second, you could feel it downshift. And then you could downshift in the first, and of course it really downshifted in the first. So that was like, okay, so the train is trying to work, but it's not working. What's the situation there? At the end of the day, we're still not 100% sure. My gut feeling, Jonathan's feeling, and another friend that does transmissions thinks that the diode, the sprag, is not grabbing the drum, so that when there's no load, it can grab the drum and give you the gear. But when you're driving on the road and you got the weight of the vehicle, you're trying to accelerate the car, the sprag can't stay locked, and so it neutrals out. And that's what we found. If we downshifted in the second from third, it would downshift, but then you'd give it gas and it would be like there's nothing there. It would just free rev. So, unfortunately, Mike talked to his builder, and his builder told us, and I didn't realize this, that if we disconnected all electronics to the transmission, it would be stuck in reverse and second. So that is a test we have not done yet. I will try to do that this week. And that will tell us whether it is indeed in the transmission or if it is something in electronics. I don't see it in electronics. I mean, here's the... rotate this around. This is the schematic from Holly, and there's really not a whole lot to it. I mean, it's the same. You got the shift solenoids, you got line pressure, and you've got your range, the range A, B, and C. That's your pressure switches. Obviously, you've got lockup, and you got transmission fluid temp, stuff like that, transmission torque converter lock engagement. So those are other things, but those have nothing to do with the car going into second gear. So I'll give you some more information on that next week. Try to Mike left the car here, so I'm going to try to move it out of its hibernation spot and test this new theory of disconnecting all electronics and forcing it to be in second gear and see how that works. That should tell us what I'm already suspecting, but we'll see. You never know until you do it. But I just want to show you guys, kind of how we're breaking down, how our thought process is for trying to diagnose a situation like that. It's not always the easy thing to do. Sometimes you can get stuck and try to figure out what's going on. That's why you have to have people you can lean on in your corner that you can ask questions to and go from there. So one thing I didn't do is I have not reached out to Jonathan to see what he thinks about making the transmission in fail-safe so it would be stuck in second. So I will ask him about that before I do this. But the builder of the unit said that he thought that would be okay to try. So we'll see. More information to come on that. I'll definitely tomorrow get a walk around video. Yeah, Ryan, diagnostic is fun. You're right. It can be, you can make yourself bald pulling your hair out with it. That's for sure. We were kind of thinking, Mike was definitely thinking it was a Holly issue, but I mean, I've put these in cars and I've never ever had an issue. Not saying it can't be that, but I just don't think it is. We've got the newest version firmware in there. I've used that firmware on other cars. It's worked on every one of them. So I'm confident that, we check the colors, the wires, they're all in the right pin locations and all the terminals are fully seated, that the only other thing it could be would be if there was a broken wire in the harness. But there's no splices on those particular wires. So it would have to be something would have had to have cut a wire. So that I did not own the harnesses out. Mike put the harnesses in himself, and he thought that they were good, that we didn't need to go to that extreme. We didn't have a lift to put the car on, so we were working with it jacked up in the driveway. So we decided we would not go to that. We would go on and see what our next thing was. You passed bald a long time ago. Yeah, well, I mean, this business sometimes will make you crazy, but it's all good. I mean, the thing is about my thinking on diagnostics is it's a pain, but at the end of the day, you'll learn something. And sometimes it's something that the next time you see something in that issue, you already been down that road. You can pop and hit it really quick and not have to go through all the hurdles you had to do on the first go round. So, yeah. So I mean, now we've got these pigtails we can test trannies with, and we'll see if this forced second gear and forced reverse works. If that does, it's another tuning tool or testing tool that we'll have in our arsenal for future issues. We're run into this again. One thing that the builder was not able to do with that transmission, he wasn't able to dyno it. His dyno happened to be broken at the time, so that would have been nice, because if he could have made it shift on the dyno, then we would have known it was definitely one or the other. Excuse me. So yeah, so that's it for that. We'll go ahead and get some more. I'll get a good walk around video on Dave's car tomorrow or Friday. I've got a little tuning job to do tomorrow. I did one a couple days ago. So maybe next week we'll do some EFI diagnostics. I worked on my buddy Norman's Corvette the other day, and he had put a new motor in the car. It's got ITBs in it, so it's got 8-stack throttle bodies on it. And he's like, man, I put the new motor in, it ran good for a long time, and all of a sudden it's doing this funky thing on cruise. whack, you go full throttle and it runs fine. But when it's cruising, it does this wacky thing. And so we went for a road test in the car and ended up finding the TPS was falling off the throttle body. And so the TPS wasn't registering when he was cracking the throttle. So the computer was trying to fuel the engine and time the engine as if it was idling. So, but I'll show you the data logs on that, and we'll see what this other Corvette that I got coming in tomorrow morning, see what we find on that one. Maybe give us some good information for another EFI Tech Day on that. And we'll see how that goes. So that's pretty much all I had for tonight. Appreciate everybody coming out and getting on it on the show. Last week, I guess because of Amelia Island, or maybe because of the thumbnail, I don't know. But man, last week was huge. We had almost 400 views during the live show last week. That was incredible. I think that was a new channel best. But still, I appreciate all you guys coming out, spending your Tuesdays with me. Hopefully, it's information you can use someday. You may run into something and say, we talked about that. Go back and find that that show and relive it and maybe help you out through a hard part. But I think that's about all we really got for this week. So everybody have a great week. Again, smash the like button and subscribe if you aren't subscribed. Just like everybody says on their channels, about 60% of the views on the channel, whether it's a live show or videos or whatever it is, only about 40% are actually subscribed viewers. So if you haven't subscribed, please subscribe. It's free, and you won't get spam. You won't get any of that stuff. It just gives you instant notification on new videos, and makes it easy to come back and find it if you want to come back and see another video. So anyway, I'll see you guys all next week. See ya.